Good day, ladies and gents. All right, so today we're going to be backtracking and go to page 23. So let's just get started. So this was a PowerPoint, but we're not going to do the PowerPoint. I'm just going to do it for you. So let's just jump right into it. All right, so we want to prove that these two triangles are congruent. So at this moment, we already know that this side's equal to that side and this side's equal to that side. We need one more bit of information at the very least. So the bare minimum I can do are vertical angles. This and this are equal to each other. So if you travel around the triangle, so let's just write vertical because that's what we just did. So you can just be mindful of that. So when you travel around the triangle, what do you have more of, angles or sides? So on one triangle, I have more sides, so I'm going to go to the third side, and now I can go in a circle. It doesn't matter which way you go. So if I go in this way, I get side, so there's nothing here. I hit side 1, angle 1, side 2. So side 1, angle 1, side 2. All right, and if I go look at the other one, what do I have more of, angles or sides? Sides, so I have to go to the third side. Now go in a circle. It doesn't matter which way you go. So if I go this way, nothing. Oh, side 2, angle 1, side 1. Okay, now are these two exactly the same? No. Okay, well maybe I just went in the wrong direction on one of them. So if I just take one of them and completely flip it around, so that'd be side 1, angle 1, side 2. Now do they match? Yes, they do. So yes, this is congruent because of side, angle, side. And there's your answer. Okay, let's do the next one. Okay, so at this moment, I have this side equal to this side, and I have this side equal to this side. I need one more bit of information. So what do you think you're going to do? Okay, most of you guys are like, oh, this side's equal to itself. So 1, 2, 3. Now, why did I use 3? Because 1 is already being used, a double is already being used, so I'm going to use a triple. So I have 3. Okay, so now I'm going to cover up this side. So I'm going to cover up this triangle. Just focus on this one triangle. Okay, they're all sides. So if I can go in any direction, really. So I just like going in numeric order if I can help it. So that's a 1, a 2, and a 3. So side 1, side 2, side 3, because it's all the sides. It's not like, oh, I have more sides than I have angles. Like I could start at an empty side. This one, there's no emptiness to start at. So I just went in order from smallest to greatest. And same thing over here. I could do side 1, side 2, and side 3. Awesome. Are these exactly the same? Yes, they are. So yes, because of side, side, side. All right. Okay, let's go to number 3. Okay, so number 3. So I always like to do the givens first. So the first given they give us was IE is congruent to GH. And that was given to us. And now we label it. So I'm going to zoom in so you can see this a little better. Okay, so that was given, and now we'll make sure that's labeled. So IE is equal to GH. Yep, they both have singles. So that's done. Check. Okay, this one, EF. So EF is equal to HF. How did we know that? That was given to us. And make sure that's labeled. EF is equal to HF. Okay, so boom. Now midpoint. Okay, so that part is important. So I'm going to put a little box on there. Okay, so that's super important. Okay, so that is going to be a chunk, meaning that this is going to give me another idea. This is going to lead to something else. So F is the midpoint of GI. Okay, how do we know that? Given. And this is going to bring us to another idea. So F is the midpoint of GI. So what got cut in half? GI. So this got cut in half. And so 1, 2, 3 would be equal to 1, 2, 3. So because that's midpoint, right there is midpoint. So this is equal to this. So I'm going to say FI is equal to FG. Or I could say vice versa. IF is equal to GF. Now, how did we know that? What was said in order for that to happen? And that was definition of midpoint. Or if you can just point out like, oh, I said midpoint, look for something that has the word midpoint, and that's your answer. So midpoint. Okay, so this idea generated another thing saying that these two things were equal. That's what we wanted. Boom, got that. Now, do we have enough information? Now that we've done all of our givens, do we have enough information to prove that these are equal? Yes. This would be side 1, side 2, side 3. Same thing here. Side 1, side 2, side 3. So because it's side, 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 these two triangles are equal. So we're just going to copy paste what we're trying to prove. Okay, boom. So those two triangles are congruent because of side, side, side. Anytime that you have triangles are equal, your only choices are side, 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 side equals side, that stuff right there. If you put anything else, you being super silly. Okay, now you remember how I said that this is a chunk. So this is a chunk. So be mindful that if this gets moved, if the F is the midpoint gets moved, so does this. So this always stays together no matter what. So remember, they will not always give you the givens in order. They will not always do it in order. So something that might happen, and I have some room up here, so I'll give you a little bubble thought here. So something that might happen is that you're going to be filling in a chart. So it would go IE is equal to GH. How did you know that? And then they'll say, oh, there's another given. And then they'll say, oh, because of definition of midpoint. And then they'll give you another given, right? So and this is you filling out the chart. And then the last thing would be triangle is equal to triangle and y. Okay, so something that might happen is this. So we know that IE is equal to GH. You would label your picture. Awesome. How did we know that given? Now here's the thing. You see definition midpoint? How did you, that would have to be generated by something that was given to you. So this is the chunk that I was talking about. So this chunk stays together. So whatever this given was generated the definition of midpoint. So this would have to be something about the midpoint. So F is the midpoint of blah, blah, blah. That goes here, and we would say that Fi is equal to Fg. So even though, so most of you guys are going to go, oh, this is the other given. So this, some of you guys are going to go, oh, EF is equal to HF. And then down here, this is definition midpoint. It's the chunk. They move the chunk in a different order because they're tricky little buggers. So what was the only other given left over? And this is where I put EF is equal to HF. So what I'm trying to point out is this chunk needs to stay together. So if you have definition midpoint, the thing right before it has to be about the midpoint. So be careful about that. That's why I keep talking about the chunk. Good news, you will be filling in a chart. You'll not have to do it cold turkey like I'm doing right now. So just pointing that out. Okay. All right, so let's look at number 4. Let's look at number 4. All right, so number 4. Oh, yeah, let me point out something else. I recognize that there are vertical angles here, but you have to do the givens first. If the givens is enough to prove the triangles are equal, you have to work with that. So yeah, there are vertical angles here, but we didn't need it at all. So just move on. Okay, so right here, we have this side is equal to this side. We have this side is equal to that side. All right, that's not enough. That's only 2 bits of information. I need something else. So I have vertical angles right here, right? And that's all I have. Well, is that enough? Well, let's see. What do I have more of, angles or sides? Sides. So I'm going to go to the third side and go in a circle. I get side 1, side 2, angle 1. Okay, go in order. Go in big circle around here. That would be angle 1, side 2, side 1. They do not match. Okay, let's try it. Maybe if I just flip one of these around. That'd be angle 1, side 2, side 1. Okay, do they match? They completely match. However, you just told me the word ass, and ass is bad. Ass and ass backwards are bad. So this is no good. This is not congruent. That's the answer. And can you tell me why? Because of ass. All right, so no I's. All right, number 5. All right, so number 5, let's see. We have this side equal to that side, that's 1 bit. We have this angle is equal to that angle, that's 2 bits of information. We need 1 more bit of information. What do you think you're going to do? Okay, it's not vertical. It's reflexive. They share a side. So I'm going to put 2 notches because singles are already being used. All right, I'm going to cover up one of the triangles. What do I have more of, angles or sides? Sides. So I'm going to go right here. Let's go in a circle. I get side 1, angle 1, and side 2. All right, over here. What do I have more of, angles or sides? Sides. So I start here, go in a circle. I get side 1, angle 1, side 2. Do they match? Yes, they do. And if they didn't, just flip one of them around and they would work. So just point that out. So now the order matches, which that's what happened up here, but is SAS good or bad? It's good. So yes, this is congruent because of SAS. Be careful. A lot of people flip it to ASA. It's just something that we do. Just be careful that you have more sides. Make sure you have more sides when you put that in there. We can go a step further saying what the triangles were. So if I started you off and said triangle, let's just go A, B, C. What would be that? What would be congruent to that? All right. So A on this triangle matches what on this other triangle? So A is a single angle. Where's the single angle on the other triangle? C. Okay. B. So we went A, B, C. Now we got to describe that path somehow. I did my single angle. I went down my single side, and then I went down my nothing side. So that's the only way I can think of describing this. Do that same path over here. So A was a single angle, so was angle C. Then we went down a single side, so let's go down a single side, and then we went up the nothing side. So it's this. So it's C, D, A. All right. Okay, let's go ahead and flip to page 24. So we're on page 24. Okay, just go through the motions. So every time they say something's equal, mark it. All right, so we know that BC is equal to DA. How did we know that? Given. And is that labeled? BC is equal to DA? Yes, it is. So we have that one bit done. All right, then they said this angle is equal to that angle. Okay, try to not overthink it. Angle B is equal to angle D. Well, crap. B could be this angle up here or this angle down here. Same thing with D. All right, so, oh, wait, they already have something labeled, right? So CBD, CBD, that would be the top of B. That's already labeled, is equal to ADB. That would be the bottom of D. That would be the bottom of D. ABD is the bottom of D. And they already labeled that. Awesome. So angle CBD is congruent to angle ADB. How do we know that? It was given to us. Wasn't that sweet of them? Okay, now we're trying to get that the triangle is congruent. So I only have 2 bits of information so far. I have a side and I have an angle. I need 1 more bit of information. So we used up all of our givens. What's another thing we can do? Reflexive property. So this, I'm going to put a double on here because the singles are being used elsewhere. Now the question is it BD is equal to BD? I should have written over here, so hold on. So is it BD equal BD, or is it BD equal to DB? That's the question. Okay, if you're not sure, look at what you're trying to aim for. See, B on this triangle matches with D on the other triangle. So that should help you out. All right, so on this triangle, it would be a single and then going down the double, so it'd be the single going down the double, so that this is the better choice. Sometimes they won't give you that better choice. Sometimes this will be a possible answer, but this is the best answer. So BD is equal to DB. How do we know that? Reflexive. All right, so now we have 3 bits of information. So we're trying to prove the triangles are equal. So once you prove the triangles are equal, you're not going to label anything else. So triangles are congruent because of when you travel around this, what do you have more, angles or sides? Side, so you go to the third side, go in a circle, and I get side, angle, side. So those two triangles are congruent because of side, angle, side. All right, number 7. Okay, so midpoint. Ooh, that's nice. Midpoint. Midpoint, super important. So for midpoint, they only gave us that. So X is the midpoint of AG and NR. Okay, so that was given to us. Okay, so that's a chunk. So this chunk is going to give us some ideas. It's a midpoint of 2 different things. It's a midpoint of A to G. So here's AG, cut that in half. This is equal to this. So AX is equal to, so if I went AX, that'd be equal to GX. That would be the best answer right there. How do we know that? What was said for that to happen? We said the word midpoint and made this happen. So definition of midpoint. Okay, and we took care of that one right there. Boom. Then we also said it's midpoint of NR. So NR got cut in half. So I'm going to put double, double. So NX is equal to RX. And why? Because that as well is a definition of midpoint. Because we said midpoint, this happened. Oop. Okay. So we have just done 2 different things for the given, and if filtered off to this. So right now we only have 2 bits of information. 1, 2. I needed something else. What do you think you're going to do? So after givens, what do you try? You try the reflexive property? Not there. And then you try the vertical. Ah, there's vertical. Angle X is equal to angle X. All right, we got to be a little more specific. Angle AXN, where X is the middle of the angle, right, is equal to angle GXR. Okay, so now how do we know that? Because of vertical angles. Or verticals, whatever. Okay, now we have all 3 bits of information. Now we can say triangle is equal to triangle. So ANX is equal to GRX. So those 2 triangles are equal. Why? We would travel around and we would get side, angle, side. We would travel around and get side, angle, side. All right, sweet. Just rolling with this. All right, number 8. Okay, so we know that angle M is equal to angle K. That's already labeled. Awesome. And it's given. They also said that WM is parallel to RK. So this and this are parallel to each other. That was given to us. Okay, now that's a chunk. That's going to be a chunk of something. That right there, that's going to be a chunk. Okay, so when things are parallel, your best friends are alternate interior and corresponding. So we're going to turn that until those 2 lines are parallel, are horizontal to us. Okay, so does this triangle look like a copy paste? Like that means you have, bad example, this and this. This looks like a copy paste. I just moved this to here. That looks like a copy paste. That's not what we have here. This does not look like I just slid it over. No. So if it's not a copy paste, we're not going to do corresponding, where these 2 angles would be equal to each other. So corresponding is not what we're going to use. We're going to use alternate interior, where you do a Z. So these 2 angles would be equal to each other. You do a Z, those 2 angles are equal, or you do a backward Z, where these 2 angles are equal. Okay, so I'm going to do a Z. So I can't do a Z like this. Let's see. I can't. Z like this doesn't work. Ah, Z right there. That's perfect. So this angle, just that little part right there, not the whole thing, just right here, is equal to, in the other inside corner, 1, 2, right there. All right, let's turn it back to normal. So because of parallel lines, I know that angle W, the top of angle W, so that's angle MWR. So this W right here on top is going to be equal to XRW. Sorry, KRW. So KRW. So that'd be R on the bottom part. So W is equal to R. How do we know that? What just happened for that to happen? These parallel lines? That would be alternate interior. That's what we just used. We used alternate interior angles. Okay, so far we only have 2 bits of information. These 2 angles are equal, and these 2 angles are equal. I need something else. Well, I already did my givens, and even the chunk of the given. I need something else. Okay, so once you're done with the givens, you would try reflexive property, and you would try vertical. Okay, vertical's not there, but reflexive is. So WR is equal to WR. So the question is, are we going to do WR is equal to WR, or are we going to do WR equals RW? So let's see. If you're not sure, let's do it this way. WR would match up with RW. So I'm going to look at, this is what I'm trying to prove. So if that helps you out. So this is the better answer. They might give you this other option, but if this option is available, always choose that one. So WR is equal to RW. Why? Because of reflexive property. And finally, now we have enough bits of information, so we can say triangle is equal to triangle. So WMR is equal to RKW. What happened? That would be, so what do you have more of, angles or sides? I have more angles. So I'm going to go to the third angle, go in a circle, I get angle, angle, side. All right, sweet. Just rolling right along. Okay, number 9. All right, let's just go through the motions. Have no idea what's going on. We're just faking it till we make it. So angle S is equal to angle Q. That's already labeled. We knew that because it's given. Awesome. And then they say, ooh, something bisects. All right, so that's a chunk because that's going to lead to something. RP bisects angle SRQ. Now, bisect means it got cut in half. Now, what got cut in half? It bisected this. This is the thing that got bisected. This is the thing that got dissected. So what got cut? R. So find R. That got cut in half. So this angle, I'll put a double, is equal to this angle, I put a double. Because singles are already being used, I put a double on here. Okay, so the bisect was given, so that's a chunk. So we now know that angle R is equal to angle R. So this angle would be SRP is equal to QRP. So angle QRP. So angle R is equal to angle R because of what word? What word was said for that to happen? Definition of bisector. Or more specifically, angle bisector. What got cut in half? An angle. So angle bisector. But just look for the keyword bisect and you're fine. Okay, so we have 2 bits of information. So single angles and a double angles. That's still not enough. I need something else. So after the givens, you would try either vertical or reflexive. Vertical is not available. Reflexive is the thing for us. So PR is equal to PR. Because if I do PR here, that'd be PR right there as well. Okay, reflexive property. Okay, so now we have enough. What do we? So enough bits of information. We have 2 angles. So go to the third angle, go in a circle. We would get angle, angle, side, or side, angle, angle. Both the same. So triangle is equal to triangle because of that. So SRP is equal to triangle QRP. All right, rolling right along. All right, let's go to page 25. Page 25. Moving right along here. Okay, so page 25. So we're on number 10. Okay, so angle N is equal to angle N because it was, N is equal to S because that was given to us, and that's already labeled. Line L bisects TR at Q. So right there. that's a chunk. So we already took care of that. But this is a chunk. So line L bisects TR at Q. So I heard a lot of bullshenanigans in there. Now, let me just ask you this. What got cut? What got bisected? What got dissected? Bisects TR. TR is the thing that got cut in half. Just focus on that and you'll be just fine. So TR got cut in half. So this is equal to this. So we know that TQ is equal to RQ. And that was a chunk. So what was said for that to happen? I said the word bisect. So definition of bisect or bisector. Okay. All right. And then, well, we did all of our givens. Boom, boom. We need something else. Okay, reflexive property, not there. There's no side that the two triangles share. So if I draw this triangle, do I overlap when I hit the other triangle? No. So the only other thing is vertical angles. So this angle, I'm going to put a double because single's already being used, is equal to this angle. So basically angle Q is equal to angle Q. So I'm going to say angle NQT is equal to angle, so N sub S, so SQR. And why? Because of the word vertical. And now I can say triangle whatever is equal to triangle whatever. And the reason why, let's see, what do we have more of, angles or sides? Angles, so go to the third angle, go in a circle, and we get angle, angle, side. All right, number 11. All right, so number 11, we have angle SPT is equal to angle OPT. So basically, P is equal to P. Ooh, that's nice and labeled, and that was given. Then they said SP is equal to OP. Okay, good. SP is equal to OP. How did we know that? Once again, it was given. Okay, so there was nothing that filtered out of that. So I used up all my givens. There's no chunks. So I need something else. So vertical is not available, but reflexive is right here. TP is equal to TP. And I'm going to put double because singles are being used. So TP is equal to TP. Why? Because of reflexive property. Okay, so we now have 3 bits of information saying that they're equal. Okay, so we need to prove that these triangles are congruent. So triangle whatever is equal to triangle whatever. Why? Okay, what do you have more of, angles or sides? Sides. So go to the third side you don't have, go in a circle, and you get side equals side. So the question is, what would be the letters? So don't reinvent the wheel. Like they already gave us the order of letters somewhere else, so just use that. But I see SPT, where I went down my single side, up my double. So do the same thing here. Down my single side, up my double. So that's OPT. But we haven't proved what they wanted yet. They didn't want the triangles, they wanted this. So once you prove the triangles are equal, you can go this extra step in saying angle S is equal to angle O because of CPCTC. So we got that. Awesome. Okay, so we are going to be dealing with triangles are equal, and that's always like side, 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 side equals side. But anytime that they are going to be using like, oh, prove that these two things, these rando things are equal, it's always going to be CPCTC, and the thing right before that is proving that the triangles are equal. That'll save you a lot of hassle. Oh, look, this is another CPCTC idea right there. And the thing right before it will be, hey, the triangles are equal. All right, let's just fake it till we make it. YT is equal to YP. Yep, they labeled that. That's given. C is equal to R. Awesome. Angle C is equal to angle R because of given. Now, I know you want to go, hey, vertical. No. 2 reasons. 1, this is not a straight line. You see how it kind of like notches over a little bit? Like it's kind of bent. Okay, that's 1 reason. The second reason is you always have to do the givens first. If that's enough information, you have to go off of that. So they also said that T was equal to P. So let's do angle T is equal to angle P. Why? Because it was given. Now, What do you have more of, angles or sides? Angles. Go to the third angle, go in a circle, we get angle, angle, side. So because of angle, angle, side, the two triangles are equal. All right, what were the triangles? Okay, I'm going to do single, double, nothing. So CTY. Do single, double, nothing, do the same pattern on the other ones. Single, double, nothing will be RPY. Okay, so now the last thing you always write is what you're trying to prove. And the reason in this particular case is CPCTC. So if you had to go a step after the triangles are equal, it's 99% of the time CPCTC. All right, so we're almost done. Okay. So we have this page in the back. So let's keep going. All right, so 13. We know that BE bisects AD at C. All right, I just heard a lot of bullshenanigans. That was given. So that's a chunk, right? What got bisected? What's the thing that got cut? AD. So AD got cut, so this is equal to this. So AC is equal to DC. Why? Because I said the word bisect. Because definition of bisector. Just look for the word bisect and you'll be just fine. Okay, so that was a chunk right there. So those two are going to always stay together. Okay, they also said that AB was perpendicular to BC. DE is perpendicular to EC. Okay, so that's given. And so they might, so because of that, so AB and BC, they are perpendicular to each other, so that means that they intersect at a 90-degree angle. Same thing with these two. So that was given, so we can actually filter into something. So we're trying to always get to something is equal to each other. This did not say things were equal, so that's going to lead to something that's equal. And what's equal? Oh, we just found out that this is 90 degrees. We just found out that this is 90 degrees. So guess what? Angle B is equal to angle E, which is equal to 90. Why? What was said for that to happen? The fact that we said perpendicular stuff. So that's a definition of perpendicular. That right there is a definition of perpendicular. Okay, so this is a chunk. That's another chunk. So that was another chunk, and we took care of that. Boom, boom. And then they also said that AB was equal to DE. AB is equal to DE. Why? It was given. It's already labeled. Now, if you travel around the triangle, we get AS. Angle 90, side 2, side 1. Same thing over here. But we're not allowed to have AS. The only time we can have AS is if we have a leg, hypotenuse-leg. So is this a right triangle? Yes, it is. So it's all right. So the two triangles are equal because of hypotenuse-leg. So those two triangles are equal because of hypotenuse-leg. And what were the triangles? ABC and DEC. All right, let's flip over to the back. Page 26. Okay, so page 26, we're on this right here. Okay, so we already know that these are given. So we said XR is equal to TR because it was given. We also know that angle X is equal to angle T, which is 90 degrees because it was given to us. And we need at least one more bit of information. Reflexive property. RV is equal to RV, and that's because of reflexive property. Okay, so these two triangles would be equal to each other. So if I go XRV, so X was a 90, so that'd be T, RV, RV. Now, why would those two triangles be equal? If you go around it, you get angle 90, side 1, side 2. Ooh, we can't have AS. Oh, so they matched up. That's awesome. But we're not allowed to have AS, so it's hypotenuse-leg because it is a 90-degree angle, so hypotenuse-leg. Okay, so down here, there are actually kind of three typos here. Let's go and fix the typos. right, first of all, that's not an ABC triangle at all. So on number 2, let's fix that. That's really triangle QRP. Sorry, QPR. So QPR is congruent to triangle STR. So that was one typo. And then on number 4, this is supposed to be AB is equal to DE. And this right here was supposed to be triangle ABC is congruent to triangle DEC. Those were the 3 typos. Okay, so let's see if you guys can do this. So try these 4. You should pause the video real quick. Pause these. See if you can find out if these are congruent or not, and if so, why. So you should pause the video and do that. Okay, hopefully you would pause the video. Let's see what you guys got. All right, so I know that this and this are equal. I know these 2 are equal. I need one more thing. Ooh, reflexive property. 1, 2. So that's equal. When you travel around this, why are these 2 triangles are equal? That'd be side, angle, side. Okay, so we did the reflexive property. Just in case you were curious. Okay, number 2. We have these 2 angles are equal. We have these 2 sides are equal. I need something else. Ooh, vertical angles. So I put doubles. So vertical is the thing I used. If you travel around the triangle, what do you have more of? Angles or sides? I'm sorry, it's upside down. Don't know how I did that. Okay, so what do you have more of? Angles or sides? Angles. So go to the third angle, go in a circle. We get angle, side, angle. All right, number 3. So we already know that LM is equal to JM. We know this is 90 degrees. So if this is 90, over here would be 90. So if this was 100, this would have been 80 because it needs to make a rainbow of a straight line. Okay, just pointing that out. Okay, I have that. Oh, I need something else. That's only 2 bits of information. Ooh, reflexive property. 1, 2. That's a reflexive property. All right, if you travel around the triangle, we get angle 90, side 2, side 1. Same thing here, angle 90, side 2, side 1. Okay, the order matches, but we're not allowed to have ass. Ooh, but we can have ass if it's a right angle, and it is. So that's a hypotenuse-leg. We can have an ass if we have a leg. And number 4. So these right here are equal to each other. These 2 angles are equal. And what else? We can find the vertical angle. So because of vertical, we have this extra thing. What do you have more of, angles or sides? Angles. So go to the third angle, go in a circle, and we get side, angle, angle. Or you could say angle, angle, side, and there you go. Okay, so we're almost done, guys. We're going to do one more page. One more page. Let's just do it. Let's do it. We are on page 33. Jump to page 33. Let's do it. So everyone's on page 33. All right. Okay, so on page 33. Okay, number 1. All right, so on page 33, number 1, we're just getting a lot more practice, guys. Just a lot of practice. Okay, so on here, we need to travel around the triangle. Now, it's kind of hard to see these things. Just go with the flow here. So Q, Y. Okay, so there is a single angle right there. Here's a single angle here. That's a single side. That's a single side. That's a double, and that's a double, just in case you couldn't tell. All right, so if what do we have more of, angles or sides? Sides, so go to third side, go in a circle. We get side 1, angle 1, side 2. Do the same thing here. Side 1, angle 1, side 2. Do they match? Yes, they do. So this is good. So because of side, angle, side, triangle. Now, if I said QYT, I went my single side, then my double. Do the same thing here. So single, then double. What would be the letters? CKP. Okay. All right, so Now, these are just more examples on how to do things. This is not as really important as anything else. We already seen like 1,000 examples of this. So just in case you're curious, here are those answers for page 33. If you just want to look at that and see if you're going to be getting the right answers. So feel free to try those on your own and see if you get the right answers. All right, I have one more problem that I want to do. Just get you guys in the right mindset. We're going to go down to number 9. Okay, so number 9. All right, so let's do this. Okay, so here we go. They said AB is equal to CD. Now, that's what the given is, right? But see, they might do this in a wrong order. They might mix this up, right? So, for instance, right here, do you see this? This given midpoint right here, that's going to be a chunk that goes together. So, if they say midpoint, the thing right before it are going to be going together. So, was there a given about a midpoint? Yes. So, D is the midpoint of BE. Okay, so we're just going to go out of order, which is totally fine. D is the midpoint of BD. So BE is the thing that got cut in half, so this be equal to this. So because of the definition of midpoint, BD is equal to DE, or you could say ED. But we're just going to go ED just for the heck of it. So it might be this one, or it might be this one. So I don't know which way is the better answer. So just be mindful. It's one or the other. Okay? So it's one or the other. I'm not sure which one's the better one. And if you're not sure, you can actually look up here. BD on this one would match up DE on this one. So this will be the better answer. So this one's no good. All right. Okay, because that's our goal, right? Okay, and then let's see, what else? Oh, here's another given right here. So given. So they said that things are parallel. So that's a chunk. They said things are parallel, so that's going to be a chunk. So that's a different chunk, so I'm going to use a different color. So these are going to stay together no matter what. So if they're parallel, then they said angle B is equal to D. So B on this triangle is equal, I'm just going to do a single, is equal to D on this triangle. Okay, and Y. Now, what does this look like? Does this look like a Z or does it look like a copy-paste job? That looks like a copy-paste. That's corresponding angles. And finally, what was the only given all by itself? That was AB is equal to CD. Oops, I already had a single. Oop, I should make that a double. Okay, so now we're saying that the true triangles are equal. Why? If you travel around it, you get side, angle, side. So just fake it to the make it. Hopefully that helped you guys out, and hopefully you guys have a wonderful and glorious day.